In this video, we're going to be learning about linear inequalities. You may be asking yourself, what is a linear inequality? Well, oddly enough, you have been using linear inequalities many times throughout your life. Even at a very young age, you understood them. Now we're just going to be applying a mathematical reasoning to it, or symbolically writing it down. So let's think about this. When you were young and you had that ride that you wanted to go on, and you saw the sign that said, you must be this high. You understood what that sign meant. That sign technically is a linear inequality. And we'll learn how to write that symbolically today. Another example would be, now that you guys are getting close to driving, well, you guys see the speed signs and you know exactly what those speed signs mean. When you see the speed sign that says maximum 60, you know that you have to be below 60. That is all that's permissible, otherwise you could get fined. You understand that sign, and that technically is an inequality that you understand. Inequalities are a lot like equations, but instead of having one variable equal to only one value, our variable could equal many values, or even possibly an infinite amount of values. Let's take a look at our speed limit, for example. When you're driving and you see a sign that says maximum 100, you know you're allowed to go 95. 96, 97 kilometers an hour. You're allowed to even go 50, 40, 60. You could go anything under 100 kilometers an hour. Therefore, we have many answers that could fit this variable. So here are some symbols that we need to know. This symbol right here, we have x, and then we have some funny symbol compared to y. We know this is an equal. This means here that y is greater than x, or x must be less than y. Okay? Because I like to think of this as an alligator mouth, and the alligator always wants to eat the bigger number. If we look at this one here, this means that x is, well, the alligator is opening this way, so x must be bigger than y. So that means x is greater than y. Let's take a look at my next one. Here I have x, and my alligator mouth opens this way, but there's a line underneath. That's like half an equal sign. So that means x can be less than or equal to y. Then here is my last one. Here we have the x again, and then now the alligator mouth is opening towards the x with an equal sign underneath, or half an equal. So then x is equal to or greater than y. So now we're going to apply these inequalities to real life. We're just going to take these signs that we've most likely seen in real life and apply them to what they mean symbolically and how we write them out mathematically. I'm going to start with this sign right here where it says no trucks over 3,200 kilograms. So what that means is this. We're going to have my x to represent my weight, and x must be less than or equal to 3,200 kilograms. Now let's look at my second one here, where it says speed limit of 55, but a minimum of 30. So we have two restrictions here. So first, when we're looking at this, we know x must be less than or equal to 55. I cannot break 55. But I also must be greater than or equal to 30. Another way of writing this is I always put x in the middle, and I'm going to put my two signs here. Okay, so x is greater than 30, put my minimum there, and my max on the other side, which is 55. So that's a second way of writing that speed limit sign. So now, my last one I want to show you is this one here, which is a little bit interesting. So we have what x cannot equal to, right? So there's no parking between 8:30 to 5. So everything around that can work. So then in this case, x must be less than or equal to 8:30. And we also know, and this is going to be a.m., and x must be greater than or equal to 5:30 p.m. So those are some examples with some signs. Here are a couple more signs that you guys could try. So now we're going to look at these inequalities purely symbolically. Well, let's take a look at my first one, A here. I have -6, it says, is greater than 6. Well, let's draw this out on a number line. If I draw this out on a number line, I could go either this way, where if I have this 0, this is going to be 6, this is -6. Or I could look at on a number line vertically, where I have it like this, where I'm going to have 0, -6, and +6. Well, looking at that, no matter what, this side is bigger than this. Here, this is bigger than this. Therefore, this here is false. Let's try the next one. It says 7 is less than or equal to 7. Well, I'm looking at that. 7 is actually equal to 7. But this sign also has an equal sign in it, so this one here is true. Let's take a look at C. It says 8 is greater than or equal to 7. So I'm going to draw a number line. If I drew the number line, I'm going to have, let's say this is 0, 1, 2, 3, 4, 5, 6, 7 comes first, and then 8. Well, 8 is further down the number line, so then 8 is in fact greater than 7. It is bigger, so this is true. Or you could do the vertical one if you like that better, because it kind of reminds you of thermometers, and we've all read thermometers many times. The next one, we're going to look at -1 and 0. So I'm going to look at this, the vertical time number line, 0, and -1 is below it. Well, is -1 less than 0? Yes, it is. It is below it, so this is true. Alright, so the next part it says, which of the following are solutions to this inequality? So now we're applying some symbolism and some algebra to it. So here we have when x is less than or equal to 5. So is 8, if 8 is equal to x, is 8 less than or equal to 5? Well, -8 definitely is. If I was to do a number line, we have 0, 5 is here, -8 is going to be down there. It's going to be colder. So this is true. Let's look at B. We have -3.5. Well, I know -3.5, if we think of degrees, is colder than 5, so this is true as well. What about 4? Well, 4, if we make that number line, we know 4 on this number line over here is going to be below 5, so this is true. Now let's look at 7. If we were to go to that little number line we made way back over here again, 7 will be above 5, so this is going to be false. 10 is also above 5, so this is false. And then last we have 5. Well, 5 is equal to 5, and in my symbol here, we says it can be equal to, so this is true. So in previous examples in the video, I showed you how to use number lines to help you understand which number is greater or less, which I strongly recommend you do. But now we're going to look at how we represent these inequalities on a number line, which becomes important. Now, the greater than and less than symbols are represented slightly differently than the greater than or equal to or less than and equal to symbols. So our greater than and less than symbols are open circles. And our greater to and equal to are going to be closed circles. So let's see what that looks like here. I'm going to have my first example, where here we said x is greater than 2. So first we look at this symbol. This is the red, so it's an open circle. And it says it's greater than 2. So I'm going to take any number. Is 3 greater than 2? Yes, it is. So it's going to go this way. Now, let's look at my next one. We said x is greater than or equal to 2. So now I'm going to have to use, we're looking at this symbol here, and that means we're going to have a closed circle. So in this case here, we look at 2 and we are going to close it. And we want something greater than or equal to 2. The reason why it's closed, I want you to think of it this way. See the top circle here in the red? it's open because it cannot ever equal to that. The blue one here is closed because we can actually equal to 2. It can actually come to 2 and touch it. Okay, so think of it that way. Now, here it says graph the inequality on the number line. So I want you to quickly pause this video and try and graph these 3 inequalities. Now that you're back, let's see if you're right. So the first one here, we're going to have b is less than 1. So there's no equal to, so that's going to be an open circle. And we want b is less than 1. Well, 0 is less than 1, and 2 is greater than 1. So this side fits my situation. My next one here, we're saying 4 is greater than x. So in other words, the alligator is eating 4, so x must be less than it. And there's no equal sign, so I'm going to have to keep this open as well. And if we look at this, x must be less than it. Well, then 4, so is 3 less than 4? Yes, it is. So we're going to go this way as well. Now, let's look at my last one here. I have x is greater than or equal to -1. Since we have the equal to sign, I'm first going to find -1, and we're going to put a circle and fill it out. And now x must be greater than or equal to -1. So is 0 bigger than -1? Yes, it is. So now I'm going to go